What's up, guys? Thanks for tuning in. Today we're going to be learning about systems of equations. This is a heavy hitter when it comes to algebra, so I'm hoping you have some time to chillax and learn a little something. But either way it goes, just be ready because it's about to go down. What up, what up? I am your teacher and facilitator, D Math Professor. And guys, I appreciate you taking the time out to come see what's really good. Today we're going to be learning about systems of equations. This is a heavy hitter when it comes to algebra. And there are a handful of heavy hitters, but systems of equations sits at the top as one of the heaviest hitters in algebra. It just simply means it's one of the concepts that you got to learn in algebra, but it represents such a big chunk of algebra. So we're going to go ahead and take some time and talk about this thing. And guys, you already know what time it is. If you see this across the screen, go ahead and hit me with a like or a subscribe, especially if you've been enjoying what you've been watching so far. All right, so let's get into it. So today we're going to be learning about systems of equations. Now, systems of equations represents a big chunk of what we got to learn in algebra. It is the ability to take two separate equations and then use one of three categories to describe the relationship between those two separate equations. The first relationship is a no solution relationship, right? There's nothing in common between these two equations. The second option is one solution. Now, the one solution scenario simply means that between these two equations, we were able to come up with one answer. And because we were able to come up with one answer, they have one thing in common. It means it's a one solution scenario. And then last but certainly not least, we want to look at what's called infinite scenarios or infinite solutions. And infinite solutions just means that we happen to come across two sets of equations where everything works. It's like the perfect marriage. It's like being able to find that person of your dreams. Everything, the stars align, and it's just perfect. Enough yip yap, let's jump into what we came here to do. Well, we see that tickets for a concert cost $10 each if you order them online, but you must pay a service charge of $8 per order. The tickets are $12 each if you buy them at the door on the night of the concert. Write a system of equations to model the situation, let C be the total cost, and let T be the number of tickets. Graph the equations and find the intersection point. What does the point represent? All right, we're not going to focus on B. We're going to focus on part A, and I'm going to come back and do B. First, I'm going to highlight some key terms. I know that we're creating a slope-intercept equation for each sentence. So the first equation is going to be y equals 10x plus 8. I've highlighted some keywords. If you want to be more familiar with keywords, look at the previous video and I go into a little more detail with those keywords that we use to create these equations. The second equation is going to be y equals 12x. Okay, so the first thing I want you all to notice is that both equations start off with y equals, or they both represent y. So we're going to go ahead and set them equal to each other because they're representing the same variable. So when we do that, we're going to have 10x plus 8 equals 12x. Now I have this thing where I like to have all of my variables on one side and my numbers on the other side. So since I read from left to right, I'm going to come across this 10x first, and I'm going to tie it to this 12x, and notice that the 12x is much larger than the 10x. So the rule here is always to move the smaller value. So in this case, I'm going to move this 10x using properties of equality. That simply means I'm going to subtract by 10x on both sides. Minus 10x minus 10x. I'm going to cancel out on this left side, leaving me with an 8 equals, and then 12 minus 10 is going to give me a 2x. So 8 equals 2x. Now I'm going to solve for x, which simply means to divide by the coefficient 2. So I'm dividing everything by 2. That's going to now leave me with x equals 4. Once I've solved for a variable, that typically means I'm looking at a one solution scenario. So if I have a value for x, that means I also have a value for y. I'm going to take my value for x and plug it into either one of these equations, and I'm going to get the value for y. Now remember, it does not matter which equation you plug it in for, your answer will still be the same. Now for the sake of this example, I'm going to do it for both so that you can see that. So I'm going to plug it into the first example. I'm going to see that I got y equals 10 times 4 plus 8. I know that 10 times 4 is 40, and 40 plus 8 is 48. When I look at the second equation, I'm going to have y equals 12 times 4. And I know that 12 times 4 is 48. So in both cases, y is going to equal 48. So what does that mean? I know that Y equals the total cost and that X represents the number of tickets. It means that after I purchase 4 tickets, the cost is going to be $48, irregardless of if I buy them online or if I do it at the door. Okay, so, and then I also want to go back because it did ask that we replace, make C to represent the total cost and T to represent the number of tickets. That simply means I'm going to go back and replace my Y's with C's, and I'm going to replace my X's with the value T, which gives me the following equations. C equals 10T plus 8, and then C equals 12T. Great. All right, so we're going to move on to the next equation, or the next scenario. And this one says a plant nursery is growing a tree that is 3 feet tall and grows at an average rate of 1 foot per year. Another tree at a nursery is 4 feet tall and grows at an average rate of 5/10 feet per year. After how many years will the tree be the same height? Same concept. I'm going to go ahead and highlight some key terms and go ahead and create my slope-intercept equations for both sentences. I know that the slope in this example is going to be, for the first sentence, 1, because that is tied to the keyword per. So my equation is going to be Y equals 1x plus 3 for the first guy, and then Y equals 0.5x plus 4 for the second guy. Again, notice that they both show that Y equals one thing and Y equals another. So since they both represent Y, we're going to set them equal to each other. So now that's going to have us write 1x plus 3 equals 0.5x plus 4. Again, I like all of my variables on one side, all of my numbers on the other side. I'm going to highlight this 1x, and I'm going to look at this 5/10 and notice that the 5/10 is the smaller value. So I'm going to move that guy. So I'm going to subtract 5/10 using properties of equality on both sides, and then that's going to cancel out on my right side and then leave me with 5/10 on my left side. Now I have 5/10 x plus 3 equals 4. I'm going to subtract 3 on both sides using properties of equality. That's going to cancel out over here, and then 4 minus 3 is 1. So now I have 5/10 x equals 1. I'm going to now solve for x by dividing by 5/10, and that's going to give me x equals 2. I have my x value, so now I get to choose to which equation I'm going to plug this x value in. Remember, it doesn't matter which equation you plug it into, the answer will still be the same. For the sake of this example, I'm going to plug it into both equations. And when I've done that, I see that I have y equals 1 times 2 plus 3. I know 1 times 2 is 2, 2 plus 3 is 5. And then in my next example, I have 0.5 times 1 plus 4. And I know that 0.5 is simply half, or in half of 1. I'm sorry, half of 2 is 1, and then 1 plus 4 is 5. So in both equations, I see that y equals 5. So what does that mean? If y represents the height and x represent the number of years, then I know that after 2 years, both of these trees are going to be 5 feet tall. Okay, everybody, I hope you got a good feel for how this works. We're going to dive into some more systems of equations in the next video. Hope you have a nice day. It's been real. Deuces.